Good morning everyone. Welcome to Cbse Educations. In this video, we will cover chapter 10 of NCERT of class 10th. The chapter is about circles. So let's discuss what is circle, what are the parts. Here you can see that I have given some of the pictures of parts of a circle. So before that, let's understand what is circle. We can simply say a circle is a collection of all points in a plane which are at a constant distance from a fixed point. So that means you can see that there is a center at the middle of a circle. So we can say that all the points on a circle is at a constant distance from that center, and that distance is the radius. So you can just say the center and the circumference, the distance between them is the radius, and radius is the constant distance that we maintain to draw the circle. Now we will see different parts of a circle. This is very important because we will be using all these concepts in the coming slides. So radius is it's a very well-known thing, so I think I need not to explain this thing. Diameter is again 2 times of radius, and circumference is the locus of the point that is at a constant distance from the center. So you just can say the circle is the circumference. I mean, it's understandable, right? This is the circumference. And chord is that you can say anything that you draw inside the circle, and it's both of the ends of the chord should be on the circumference. That is a chord. And the longest chord is the diameter. An arc is a part of circumference. You can see it's a part of circumference. Then tangent is a line that touches the circle at a single point, that is called tangent. Then segment is a part of circle. So if you divide the circle into different parts and using chord, so you draw different chords in the circle and you choose any specific part, then that becomes segment. And sector, if you divide the circle by diameters, you draw many diameters and then you just choose a particular part, so that it see that part has a part of circumference and 2 radius. You just see that that part is always connected to the center, but in case of segment, the center may not be a part of that segment. So that is the difference between segment and sector. Then we will go to the next one. So let's see what is the interaction between a circle and a line. So if there is a circle and a line on a plane, then what can be the possibilities by how many ways a circle and a line can interact? So one thing can be the line and the circle, they are at different place. I mean, they are not going to intersect each other at any time. So these are called non-intersecting. The interaction is non-intersecting. Then we can go to another case, that is secant. In secant, the line crosses the circle. So here the line crosses the circle and it cuts the circle at 2 points. Here you can see PQ is the line and it cuts the circle at A and B. So AB, this line PQ is the secant. You can say AB is a chord, and A, if I will write O here, then AOB, this thing will be a arc AOB and A. I mean this area is a segment. Okay, so you just remember secant is any line that cuts the circle in 2 points. then tangent. So another interesting case can be the line touches the circle at just one point. It just touches that circle at one point, that is called tangent. So in this video we will discuss about tangent in more detail. So these are some of the definitions you can say. So a non-intersecting line with respect to a circle, that means no common point between the line and the circle. A second, the line and the circles have two common points, and for a tangent only one common point between the circle and the line, that is the point of contact, we say, the point where the line touches the circle. Now we will discuss about some properties of tangent, and we will see what are them. A tangent to a circle is a line that intersects the circle at only one point. So we can say that tangent is a special case of secant. So how we can say that? Let's see. In figure 1 you can see AB. AB is a secant. Now if I will try to rotate AB about the point P where it cuts the circle, if I will try to rotate AB about point P, then I can get this line in next stage, then this line in next stage, then this line in next stage. So if you keep on rotating, at some point you will find a point where the line just touches the circle. It just cuts the circle at a specific point. It doesn't cut the circle at 2 points, right? Here you can say it's A dash and B dash. By rotating AB, you can just get a position of A dash and B dash where it just touches the circle. So then that secant becomes a tangent there, right? So we can say that secant is a special case of tangent. Then the common point of a tangent and the circle is called a point of contact. So where the circle and the tangent, where they touch each other, like P dash and Q dash and this circle. So this point is the point of contact. Now the tangent is said to touch the circle at the common point. So it's clear now. Now we will discuss one theorem related to tangent. The tangent at any point of a circle is perpendicular to the radius through the point of contact. So a tangent at any point of a circle. See, how many tangents can be drawn over a circle? There can be many, because there are many points. You cannot count the points over the circumference, right? So at every point we can draw a tangent, right? So a tangent at any point of a circle is perpendicular to the radius through the point of contact. See, this is the circle, xy is the tangent, P is the point of contact, O is the center. So they are saying OP. So I joined the center and the point of contact. This OP will be always perpendicular to the tangent at the point of contact. So let's understand how to prove it. So see, here it is given the description of the figure. You just can go through it. Then we can see that take a point Q on the xy other than P and join OQ. So Q is a point on the tangent and it is other than the point of contact. Now you join OQ, that is center and that point. Okay, and that point, see, that point is a point on the line, and we just have a common point where it touches the circle, other points are outside the circle. So this OQ, this line OQ is a connection, we can say, between the center and the point outside the circle. So therefore OQ is longer than the radius OP of the circle. See, the radius is the center and the point on the circle. If we are connecting any point outside circle, then it's obviously gonna to be larger than radius. So here I have taken Q, and any point I will take on the line, that line will be larger than radius. So OQ is longer than radius OP of the circle, that is OQ is greater than OP. Since this happens for every point on the line except the point P, OP is the shortest distance of all the distances of the point of O to the points of XY. See, if you will connect all the lines, all the points, if you will try to connect all the points, you can see OP is the shortest distance between O and any point on the XY, because other points are lying outside. So we can say OP is the shortest distance, and you might have known that the shortest distance between a point and a line is the perpendicular distance from that point and the line. The shortest distance between a point and a line is the perpendicular distance between them. So that means if OP is the shortest distance, then it must be perpendicular to the line. So hence proved. Now we will see how many tangents from a point can be drawn to a circle. So the point, and now let's discuss all the situations where can a point be situated. So one thing can be the point is inside the circle, another thing can be the point is on the circle, another point and another situation can be the point is outside the circle. So in case of case 1, that is situation 1, if the point lies inside the circle, now every point goes through that, if we try to draw lines that goes through that point, so if that point is inside the circle, then we are never gonna to get any tangent through that point. Okay, so all those lines will be seconds. So we will get secant, but we are never going to get a tangent. If the point is inside the circle and we try to draw lines through that point, then we are never going to get a tangent. In case 2, if the point is on the circle, then we can draw a single tangent at that point. So at every point you can just draw only one tangent. And if the point is outside the circle, then you can see P is outside the circle, then you can draw 2 tangents from P. So we will see some more concepts related to this situation. So this thing will be clear. And okay, you just remember what are the 3 situations, and in that case what number of tangents are possible. Now we will go to theorem 2. So here the lengths of tangents drawn from an external point to a circle are equal. So they are saying if we draw tangents from an external point to a circle, then the length of that tangent will be equal. So see, we discussed that if a point is outside a circle, then we can draw 2 tangents from that point to the circle. Now these tangents are drawn. Now to prove that PQ is equal to PR, we have to draw some few more lines. We will join the center with the point of contact at Q, and then we will join O with point of contact at R, then we will join O with P. Now let's see. We have to prove PQ is equal to PR. So for that, let's find whether this OQP and ORP are congruent or not. So see, OQ and OR, they both are radius, so OQ is equal to OR. OP is a common side, and you have learned in theorem 1 that OQ is perpendicular to PQ, because this is the radius and OQ is the point of contact, and we have proved that, right? So the same way ORP is also 90 degree. So can we say that OQP and ORP are congruent? Yes, because 2 sides are equal, and we have also another angle which is 90 degree for both of them. So you can just see that OQP and ORP are congruent. So that implies that the other sides like PQ and PR are equal. So the thing is proved that if we draw the tangents from an external point, then both of the tangent segments are going to be equal. So that's it about the tangent and the interaction between the lines and the circle. So you just keep practicing some of the examples, and in the coming class we will discuss some examples as well as I will give you some questions so that the concepts will be more clear. So yeah, thank you. See you in the next class.